Right, we are live now. Hi, good morning. My name is Arun Gupta, and I work for Red Hat. I'm the Director for Developer Advocacy, drive the developer outreach efforts for JBoss middleware. In this session, in about 50 minutes, the goal is to kind of give you an overview of Java E7, which is the latest release of the platform. Very fast-paced session, so you can imagine 50 features in 50 minutes. I got tons of slides, but they're all code-driven. So you'll get a quick introduction to all of these features. I authored a book, O'Reilly book. I'm looking for your hashtags and your tweets. They're at the bottom down there. So Java E7 and DevNation are your hashtags. Those are the ones that I'm looking at. So the folks with the most hashtag get the book. Okay, that's how I'm going to do it. All right, keep it simple. Now, since we have a little bit over 50 minutes, so we might be able to go a little bit slow. But the general format of this is I'll have the feature number on the top left, then I'll talk about the different specification, and then I'll talk about the specific feature. Okay, so that's the format that every slide is following in this one. So this is what I call as the pancake diagram for Java E7. Now Java E7 is the latest release of the platform, was released on June 2013. There were 4 brand new specifications. There were 3 which were majorly updated and several that were minorly updated. So overall, 16 specifications in the Java E7 platform. What I'm going to start with is, you can see the Java E7 platform at the bottom. Then the middle tier is literally the middle tier, as I say, persistence, enterprise Java beans. Part of web tier is involved in there as well. And then on the right side and the left side, you can see the specifications that span across the entire platform. You can pick and choose what you want to use with it. So what I'm going to do is I'm going to start with left-hand side, which is CDI. And then I'm going to progress through the block diagram or the pancake diagram, and I'll cover the different specifications. Now CDI. CDI was introduced in Java E6. This is the standard way of doing dependency injection in the Java platform now. It was such a fundamental change to the specification that, in Java E6, we required beans.xml to enable CDI. Without that beans.xml, CDI won't kick in. But now with Java E7, CDI is default. So that's the biggest change in Java E7. Now, in addition to that default enabling, we have also given some knobs and controls to you. So for example, if you do have a beans.xml, then there are 3 values that you can specify over there: all, annotated, and none. Annotated is the default. And by default, I mean is, if you have no beans.xml in your WAR file, and in that WAR file, any bean which is CDI scoped bean is available for injection by default. So that's the default mechanism. But if you say all, then it says, okay, every bean in the WAR file is available for dependency injection. And by none, you mean, okay, turn off dependency injection, no CDI enable for this particular archive. And this is not just for WAR file, although I'm saying WAR file, but WAR, ER, jar, whatever your scope is, it kind of governs the scope that way. A new annotation was added to CDI 1.1. This was, by the way, JSR 346, I think. It doesn't have the number, but that was JSR 346 at vetoed. Now, you are moving along in your archive, you have a bunch of beans which are getting injected. A particular bean you don't want to get injected. You just mark that bean with @vetoed. That means just that particular bean is not available for injection. Or if you have multiple packages, say test package, dev package, similarly production package, you don't want a particular package to be injected. So now, earlier there was a declarative way by which in the beans.xml you could say don't available this package, or just mark it as an alternative so it won't get injected. But now at a package info itself, you can specify @vetoed, and the moment you put that annotation in package info, that means that entire package is not available for injection anymore. Right? So lots of cool features are getting added to CDI, but those are the major ones that I'm going to highlight today. Bean validation. Now, bean validation was again a new specification that was added to Java E6. The focus was specify validation constraints on the bean. Now, those constraints in Java E6 were honored by JSF, or Java Server Faces, and JPA, Java Persistence API. So for example, in Java EE 6, you could put a validation constraint on a bean. Before the bean is persisted or updated or deleted, those constraints were validated, but it was only constructed to JSF and JPA. In Java EE 7, it's a lot more generic, in the sense you can actually do programming by contract on any method parameter in a POJO, in a managed POJO, of course. On any method parameter, you can say at not null, which is a standard validation constraint. What that means is, when this method is invoked, if the algorithm is null, that means this method will not be invoked. That's called as programming by contract. That if the contract is honored, only then the method is invoked. Otherwise, it throws a constraint violation exception. Not just method parameters, but even on the return values. So for example, here I'm saying, you passed a good credit card number, but that if I validate it, it's returning false. And here I'm saying assert true. So that means if it's trying to return false, it's again going to throw a constraint violation exception. So programming by contract means it's as good as method not being invoked. Okay, so that's sort of the idea over here. So both the parameters, that means the inbound value and the outbound values, as they are expected by the contract, they should be honored. All right, so that's sort of the biggest change in bean validation. Interceptors. Interceptors in Java EE 6 were extracted. They have always been part of EJB. Now in Java EE 6, interceptors were a lot more widely applicable. In Java EE 7, what we have done is we have added annotation by which interceptors can be applied around a constructor. So when a bean is being constructed, in Java EE 6, for example, they were allowed only around business methods. Now with Java EE 7, you could say, here is a logging interceptor, and I'm putting at AroundConstruct. That means this particular method, which is annotated with at AroundConstruct, would be invoked anytime a bean is being constructed. So a constructor of a bean. That's the sort of a big difference over here. In addition, we have also added annotations by which we can start prioritizing our interceptors. So for example, there are certain predefined values that are available to you. So you can say platform before, library before, application, library after, and so on and so forth. So by default, there is no priority assigned to them. So you have to explicitly assign a priority to them. Now, what would happen is you could have multiple interceptors bundled in your archive, and in that archive, you can start assigning priorities to them. So they will be invoked in that priority. So of course, the one with the 0 is going to get invoked, and then library before, and then application, then library after, and platform after. So depending upon what the priority value is, they get invoked in that specific order. So this is a brand new feature as part of Java EE 7. As a matter of fact, everything that I'm talking about in this presentation is a new addition to the Java EE 7 platform. All right, concurrency. Concurrency Utilities is JSR 236. The biggest change that brings, and that's, by the way, a brand new specification in Java EE 7 platform. Now, in Java EE, you cannot spin up your user threads. And the idea is, because Java EE is a managed environment, in a managed environment, there is no concept of a user thread as such. Because if it's a user thread, then the managed environment doesn't know how to manage that user thread. So concurrency utilities effectively gives you an ability to run a user thread in a managed environment. And that's sort of the big change over here. So you can say, we all familiar with the executor pattern, which is already existing in JDK. So it's basically announcing manage objects of those executor objects which are in JDK. So for example, here, I have a managed executor service. I can just inject it simply using @resource annotation. Well, that's one way. Dependency injection is all prevalent in Java EE 7. So that's one way. The second way is I can inject it using JIND lookup. So here I'm saying context.lookup. I specify the JIND name, and I get managed executor service. Both the ways are possible. Well, the third way that is also possible is, well, in each of this case, for example, what I'm getting is a default managed executor service, because this is the default JNDI name. And in this case, I'm not even specifying a JNDI name, so the default managed executor service is obtained. In this case, in the WebXML, I can specify my own executor service. I just need to specify this resource reference type, and I give a specific name. And once I give that name, then in my code, I can say, so for example, in this case, I can say lookup, and I can give concurrent/myExecutor, which is my specific name that I've defined. So 3 ways, by default injection, by default JD lookup, or application specific lookup. So that's Manage Executor service. JDK also has a Schedule Executor service. So we introduce a corresponding object of that as well, which is called as Manage Schedule Executor service. It basically allows you to submit jobs with periodic delays or after a certain delay, and then run it after a certain time. So that's what it does. Just like my executor service, I'm saying inject using a Manage Schedule Executor service over here. So just simple resource annotation, or I can do using JD lookup as well. So this time the resource name is different. So say default Manage Schedule Executor service, and just like Manage Executor service, it can also be injected in WebXML. So the 3 ways are available in this as well. Now the usage, of course, follows the standard JDK design principles. We're not adding any new usage per se. So here I'm saying, okay, I want to execute a job or schedule a job which runs every 5 seconds. So that's sort of my very first simple call. Then I say schedule at fixed rate. So I'm saying, okay, schedule the first job at 2 seconds and then every 3 seconds. So you can start using your JDK standard design principles when you're building these applications. So all of these methods, schedule, schedule at fixed rate, schedule with fixed delay, all of these methods are already existing in JDK. All we are giving you is the ability to run these in user threads, managed ones, in Java EE environment. Now the biggest difference that you get between JDK and Java EE is if these threads are managed threads in Java EE, then your class loading context, your JNDI context, your security context, all of that is available in the managed threads because the container is managing them. Prior, if you were running them as user threads, that context was not available to you. You have to do your own class loading hacks to pass on those contexts. The only context that is not available or passed over is the transaction context, because coordinating transactions across multiple threads is not a simple problem. All right, so we have a ThreadFactory in JDK. So we have a managed ThreadFactory. So just like my manage executor and manage schedule executor, I can use the resource injection using @resource, or I can do a JNDI lookup using context.lookup. So effectively, all I do is, once I get the managed thread factory, from the factory I can create a new thread, and I can say spin up a new task. In this case, this is a application managed task, so I'm saying new my task, or you can even inject a task. So say, container manages the thread factory, container manages the task, and everything is container managed. Here you're doing a mix and match of the strategies where the container is managing the thread factory, the application is managing the task lifecycle. It basically gives you just one method which says is shut down, saying, okay, if the thread, can it be shut down? And the last manage object that is available as part of JSR 236 is a dynamic proxy. Now, those 3 standard design patterns already exist for you, which were there in JDK. Here, now if you want to add contextual information to any object in Java EE, this is what this is useful for. So effectively, you can create a dynamic proxy, and you can say, to this dynamic proxy, which is attached to this object, I want to add my class loading JNDI security context information available. And the way it looks like is, so here I'm saying, okay, I'm going to inject a context service. Once I get a context service, I'm going to create a contextual proxy from that. And once you create a contextual proxy, in this case, I'm just assigning a new runnable, but you can do it in a new callable as well. So once you create the object, once you get the proxy, this proxy can again then be submitted to your executor, your standard JDK executor in this case. But because it's created as a contextual proxy, so your contextual information is still available in that proxy object. So there are different design patterns. You just need to understand which ones to use when and where. All right, so let's kind of start going up the stack now. Java Persistence API. Java Persistence API is a standard way by which you do object relational mapping. So one of the first changes over there is, up until now, for example, you could say, okay, here is my database table. From the database table, generate my JPA entities. There was no way for you to say, I'm a better JPA programmer. Now you generate my database tables from that. So what we have added as part of JPA 2.1 is JSR 339 is JavaX persistence schema generation properties. So now you have designed your entities, JPA entities, and then you can say, based upon those JPA entities, now you generate my database tables. And there are a bunch of elements that are added to my JPA model as well, which I'll walk you through that. But the idea is you have coded your JPA entity. So in this case, for example, I'm saying scripts.action is drop and create. So every time the application is deployed, you drop the tables and create the tables again. Here I'm saying scripts create target is create.sql. So not only you can generate the database tables, but you can say, okay, don't worry about creating the database tables, just generate the scripts for me. So look at my JPA entities, generate my create.sql script. So it's going to generate the create.sql script, which you can then pass on to your DBA, who can then fine-tune it, and which you can then bundle with your application if you want to. These properties are kind of useful, specifically if you're going in a cloud environment where you may not have access to directly create your database tables and all. So you can say, here is my WAR file, here is my SQL, here is my JPA. At the deployment, a Java E7 container would be automatically be able to create this. So for example, if you're running Wildfly in OpenShift, then you can supply this WAR file, just one WAR file, which will automatically create your database tables, provided your data source is appropriately configured. Not just database creation, you can actually load data as well. So DDL is the first two properties, the DML, which is data manipulation language, where you're inserting the data into the database. So your seeding of the database can be done using your properties as well. Now, once you are creating your database tables, you want to create some indexes. So this is a new element, a new attribute that is added to the table annotation. So you can say, I want to create an index. So this is on column name, well, it's a list of columns. So the first one being ISBN, the second one being number of page. So very simple. It just creates additional index. And again, this works on any of the databases, although the testing was done on a majority of databases, but it should still work on all the databases. JPA by default offers a synchronized persistence context. So what that means is when you write something to the persistence context, it is already part of a transaction. When you commit that transaction, everything in that persistence context is written to the underlying data store. Now with this, what we are saying is there is a concept of an unsynchronized persistence context, specifically in a mobile app, where you may have connectivity, may not have connectivity. So you could maintain an unsynchronized persistence context on the client side. And when you are ready, say, okay, then your entity manager, which is basically in an unsynchronized persistence context, explicitly joins the transaction. And as soon as it joins the transaction, that's when the transaction is committed. So you have the capability to check what is the availability of the transaction, what is the availability of the network connection, and then accordingly your entity manager joins the transaction and the transaction is committed. So again, a new concept introduced in Java E7. In JPA, we have the capability of saying named queries. So we could say, hey, this is my JPQL or Java Persistence Query Language, which could be defined right on top of your entity class. And you can say, here are my bunch of named queries, which are convenience queries because those queries are pre-compiled and then they're much faster at the execution time. Same way, we have introduced an annotation called as named stored procedure query. So let's say in your database, you have multiple stored procedures defined. Now you have access to them in your entity in a standard way. So you can just simply say named stored procedure query. This is the actual stored procedure name in your database. This is your convenience name. And just like any stored procedure, there are in, out, and in-out parameters. Each of those parameters can be very easily specified as part of the named stored procedure query. Right, let's take a look at transactions. JTA 1.2 or JSR 907, I think. Yeah, EJBs was the only way by which you could do container managed transactions in Java EE 6. You could do user managed transactions because there was a user transaction object that could be injected. But now with JTA 1.2, what you could do is you could make any POJO as transactional, full transactional. So for example, in this case, you can see I have a public class book rest service. On that book rest service, I've added an annotation called as add transactional. So just by adding that single annotation called as add transactional, the CDI interceptor binding, which is part of the Java E7 runtime, automatically kicks in, automatically starts a transaction for each method of this POJO, and commits/rollbacks at the end of the method. Now here, it's basically saying I'm making it as a stateless bean sort of, because I'm putting add transactional on the top. But if I could be selective, and if I want to be selective, then in each method I could explicitly specify, does it have to be transactional or not transactional? So which is where the benefit comes in. So you could start specifying at a lot more granular level on any POJO. So add transactional single annotation implemented using CDI interceptor bindings. It's good to know the details, but from your perspective, you're just using add transactional. And your usual semantics, for example, roll back on these two exceptions, SQL exception and JMS exception. Don't roll back on a warning exception or a warning, for example. So you can start specifying what those semantics look like. Now, in addition to add transactional annotation, which gives you container managed transactions outside EJB, we have also defined a new CDI scope. As part of that CDI scope, basically what you're saying is, here's a book bean, and on that book bean, I added a add transaction scoped annotation. Then the life cycle of this bean is tied to an annotation, so or a transaction. Now, if a transaction is active, within that active transaction, if you try to inject the bean, you'll get a value of the bean. Otherwise, the proxy will point to nothing. So here, for example, this is a web servlet. So this is a simple servlet. Here I'm beginning a transaction. I'm injecting a user transaction. And I'm trying to inject two instances of the bean, B1 and B2. Now, the way CDI works, it basically has a proxy to the bean. Okay, so B1 and B2 are two proxies. And if my book bean is transaction scoped, within a transaction, when I try to get the reference, both the references are going to point to the same bean because it's a transaction scoped bean. If it's not a transaction scoped bean, or if it's a dependent scope bean, which is the default, in that case, the B1.get reference and B2.get reference are going to point to two separate instances of the bean. Because the bean in this case is transaction scoped, it's going to point to the same bean instance. All right, EJB 3.2, JSR 345. Some minor additions made to EJB 3.2. The first one being, we could say, I want to optionally disable passivation of stateful beans. Because by default, the stateful beans, if they're not being used based upon certain parameters, they're passivated. But it could, if you, for performance reasons, you may want certain beans never to be passivated. So at least you have an option for that now. By just adding a simple attribute, passivation capable equals false. Another addition in terms of EJB 3.2 is asynchronous beans and non-persistent timers are now added to the web profile. These were heavily used as part of full platform anyway, but now they're added as part of this. So if you take this code, for example, just put add asynchronous annotation on a method. Now what you're getting back, so in this case, for example, or say send mail, when you take a parameter and you say add asynchronous, it's a very long task. So think about this as a fire and forget pattern. So you fire it, a method gets executed, result comes back to you or not, it doesn't matter, because there is a void return type anyway. In EJB, there is also a design pattern where you can get a future object. So that's sort of the way by which you can get a result using the future object. Now both of those are available as part of web profile. And here by persistent equals false, you're making it a non-persistent timer. Right, JMS 2.0, JSR 343. JMS was a pretty bloated API because it was designed like the last it was revised was December 2003. So a lot of changes have come into the Java platform itself since then, like generics, annotations, bunch of improvements in the runtime itself. So the biggest goal of JMS was itself to catch up with the platform. So now JMSContext is a brand new API. So what you can do is you can simply inject JMSContext. This is called as a simplified or the JMS2 simplified API. Now, if you want to just produce a message, so you say context, create producer on it, you send the message, and when you send the message, you target it to a destination and the message. That's it. Now, this one line was about 20 lines of code in JMS 1.1. Lots of runtime, lots of caught exceptions or handled exceptions then closing the connection, then finally blocks, and then catching some more exceptions in there. The code was pretty nasty and a lot of boilerplate in there. If you want to consume the method or consume the message, then you say create consumer on the same queue, you receive the body, and you know that the message is received as string.class, you just get the message back. It's a pretty fluent API, so you can start adding some values over there. Okay, I'm creating a producer, setting the priority, TTL, delivery mode. So all those semantics can be specified in the API itself. Now the simplified API and the classic API, so to say, JMS 1.1 API, they coexist. They don't mix and match though. And that was a conscious decision because JMS 1.1 classic API has been used too long to be able to make any changes to it. Now, what I showed you earlier in this case was, this is, for example, of a container managed JMS context. You can, of course, do application managed JMS context as well. In this case, I'm saying connection factory.create context. But the big difference over there being, this is actually auto-closable. So you can just put it in a try with resources block, and as soon as it gets out of scope, JMS context automatically closes for you. So you don't have to close it explicitly. New annotations added, again, further simplifying the platform. So for example, you want to create a connection factory definition as part of application deployment. So what you do is, in your EJB, so this is my simple stateless EJB, in there, all I'm doing is I'm adding this annotation called as JMSConnection factory definition, and I'm specifying my application specific factory name. And I say, this is a topic connection factory. So when this WAR file is deployed, this connection factory is automatically created for you. Prior to this, as part of deployment, you would typically give a deployment script. Oh, run your application server specific tool and create your connection factory in that specific way. But now, just the WAR file is your deployment script. So you put this annotation in your WAR file and the factory automatically gets created for you. Not just the connection factory, but even the destinations itself can be created. So you can see, for example, I'm creating my connection factory here, and then in here, I'm using my destination definition. So I just put this annotation as well as part of my WAR file. When the WAR file gets deployed, it automatically gets deployed as well. All right, Servlet. Now in Servlet, doGet method, for example, the classic way you will read the value is using a non-block or a blocking input. So here I'm saying, okay, read from the input stream. Now that is a greedy process because the thread is blocked in that sense. So with Servlet 3.1, two new interfaces have been introduced, read listener and write listener. And they are introduced on Servlet input stream and output stream. So a very classic example here of suspend and resume basically. So on these methods, I have, on these interfaces, I have methods like on data available, on all data read, and on write possible. So these methods are kind of callbacks which are automatically called and there is more data available to read. So in your non-blocking, what you do is you say set the read listener to my read listener, which is a separate class, and that listener, those methods in the read listener are called automatically when there is more data to read. So you're not really blocked in that sense. Now one of the ways, the way WebSocket works is they use an existing HTTP connection and then they upgrade the HTTP connection to WebSocket connection. And this is a standard HTTP upgrade terminology. Now, that's the way WebSocket works, but the upgrade mechanism is a lot more widely applicable. You can apply that to a much wider set of protocols, and we can talk about that a little bit later. But Servlet 3.1 introduced an API by which you can say, upgrade an existing request. All you need to do is just provide a simple web connection over here, and then the web connection effectively has an input and the output stream. So you can upgrade to completely non-HTTP specific protocol, which is basically what WebSocket is. Improve security in Servlet. So for example, here you can see I have a method. This is my web XML. It says version 3.1. This is the HTTP get method over here. And I have some authorized constraints over here, which says how my get method is being protected. Now, get is protected, but by default, all other methods, post, put, delete, are unprotected. So that's a security hazard. Now, with Servlet 3.1, there is a simple element here called as deny uncovered HTTP methods. So just by adding that simple element in your web XML, you're saying all other methods. So get stays protected per the constraints that are specified. all other methods are unaccessible now. You have to explicitly add security constraint or expose them. All right, so get on to WebSocket now. Now, WebSocket, as I was talking about, is upgraded from an existing HTTP connection. The simplest definition is it's a full duplex bidirectional communication channel over a single TCP. It's full duplex because the client and the server can talk to each other independent of each other. It's bidirectional, unlike HTTP where client talks to server and server responds back. Here, client can talk to server and server can talk to client. And the best part is over a single TCP connection, because unlike HTTP, where for each request a new TCP connection is started and terminated when the response is received, here HTTP connection is upgraded to WebSocket, and once upgraded, the TCP connection is held on to. And the TCP connection is held on to, the client and the server are able to exchange infinite amount of messages until one of them says, okay, I'm done. I don't want to talk anymore. Now here, in this case, if I want to build a very canonical chat server, and by the way, this is a fully functional chat server in like about 8 to 10 lines, which will work. So what I'm saying is, I want to set up an annotated server endpoint. So I say chat server, server endpoint. This is the URI that the WebSocket endpoint is listening at. Now the WebSocket endpoint can receive a message, text, binary, or a protocol message. Let's deal with text message for simplicity. So here I'm saying, I'm receiving a text message. So text message is represented by string. So this is my string. And this is my session object. Session is basically an encapsulation of the client and server conversation. So all I'm saying is, oh, there's a typo here. Shouldn't be session. This should be session, actually, not client. So from the session, I am getting all the open sessions. So remember, session is an encapsulation of server and client conversation. So I'm saying, give me all the open sessions on this server, and then you just broadcast the message to all the clients. In the WebSocket world, the way it operates is not peer-to-peer, but a server is at the hub, and all the clients are at the edge of the wheel. So there are all the spikes. So we have a simple at server endpoint annotation. There are also lifecycle callbacks. So I can say, whenever a client opens a connection with my server or with me as a server, call this method which is annotated on open. Similarly, on close and on error. And reasonable values are available as part of method parameters. So you can figure out, for example, what caused the error. So give me the entire throwable stack trace. Now remember, I was saying client and server are peers. They're talking to each other. So just the way you have server endpoint, you also have a client endpoint annotation. So in this case, I'm saying, okay, I'm just going to put up a POJO, make that as a client endpoint. The difference being, client is talking to a server. It doesn't have a URI to listen to. So like in server endpoint, I was specifying the URI. In client endpoint, I am not specifying the URI. I'm explicitly connecting to a server. Yeah, that's my next slide. So I'm explicitly connecting to what my server is. So I'm saying, okay, container provider, give me the WebSocket container and connect to the server. And the way WebSocket endpoint works is it uses ws://scheme. So you say, this is the URI where I'm listening to. So in this case, for example, it will be ws://localhost 8080. If that's where my Wildfly server is running, then I will say the context root, and then I will say the URI where the WebSocket endpoint is listening. So literally one class, no deployment descriptor is my WebSocket endpoint. I also have the ability to do programmatic endpoint, which gives me a little bit more knobs and dials in case I want to start configuring how my WebSocket configuration looks like. So for example, in this case, I'm saying chat server now is extending an endpoint. I need to override this method called as onOpen, and then here it gives me an endpoint configuration. The endpoint configuration itself gives me a little bit more details. I'll talk about that in a second. But for now, I can add a message handler that whether I want to receive the whole message, so I can add a whole message handler, or I want to receive a partial message, like maybe you might be getting chunks of messages. So there are different knobs and controls, as I was saying. Most of the times, the default annotated programming model works for you, but if it doesn't, then you have more controls over here. Now, in case of configuration, what you can also start doing is, for example, you can start specifying, okay, this is my endpoint config. Then, well, the way this endpoint, okay, in the programmatic endpoint, you're not specifying a URI. So the way you specify the URI is you implement this interface called a server application config. which is where you're specifying what your endpoint is going to look like, okay? And this is your final configurator class. So by default, the programming model is each WebSocket endpoint, there is a new WebSocket endpoint instance created to handle with the client. But if you want a singleton instance, for example, of WebSocket, which can talk to all the clients together, that's where you manipulate this. So you say get endpoint instance, and you manipulate that. Okay, for each client, just return a single instance only, a singleton instance. You can even start modifying the handshake as well. What are my handshake headers, requests, and responses looking like? This is at the HTTP upgrade time. So all those configurations are available to you in this programmatic endpoint. Now, I said WebSocket endpoint can handle text and binary data. You may not want to deal with the raw text and raw binary data all the time. You may want to convert your text, for example, to JSON objects, or text to POJO objects, or binary to, say, image objects, or some other objects which is more specific to your domain. So for that purpose, there is a decoder and an encoder pattern. Again, very standard design pattern, but it simplifies your code here. So instead of receiving a string over here, I'm receiving a chat message. And in the server endpoint annotation, I'm specifying what my decoders and encoders are. My decoder here is very simple. It says decoder.text. So this was a string message. So I'm receiving a string message. It says, okay, I'm going to decode a string, and I'm going to return a chat message over here. And similarly, there's a will decode message. So in a server endpoint, you could have multiple decoders, for example, and only one of the decoders would say will decode returns true. So it can peek into the message, and it can make a call that, okay, can I really decode the message? If not, I return false. If I can decode the message, it will return true back from there. Not just, well, that was the decoder, and this is the encoder now. Encoder is the one where you take the business object, like chat message in your case, because on the wire, it has to be string or binary. So encoder is the one that takes your business object and converts it into string/binary, in this case a string, because that's what eventually goes over the wire. All right, expression languages 3.0. Now, EL, or expression languages in general, has been into the Java EE platform pretty much from the very first release itself, but they've always been part of Java server pages. You've been using them as part of JSP, but there's a lot more relevance of expression languages. So this whole specification itself was extracted out of Java EE 7 and made of its own specification. So now you have this concept of an EL processor. So you get the EL processor. You can start evaluating your own EL expressions. You can define certain object instances and how to operate on them. A classic example is you can write your own configuration file, leverage the same EL mechanism that are available in a JSP or a JSF page, and use the same power, same EL engine for writing your own configuration file. So for example, I'll talk about batch in a second, but the entry point to batch processing in Java EE 7 is a configuration file. That configuration file is handled using this standalone EL processor. You can even run this EL processor in a standard JDK application as well. You don't need to have the entire full-blown Java EE stack for that. Java server faces. This was JSR 344. Few additions in JSF 2.2. The first one being faces flow. Now this is nothing new. This has existed into multiple other JSF toolkits for a while, but now it's a lot more standardized. So think about, in a JSF application, it's a typical web application. You want to bundle certain pages together, which kind of belong to a flow. Think about a shopping cart. So you have a page where you list the shopping cart, then the credit card details, shopping address, all that stuff. So those packages belong in a flow, and that's sort of a reusable flow which you can use in other parts of your application as well. Now JSF did not define, or the specification of JSF did not define any standard means of packaging those applications. With JSF 2.2, we have this concept of a faces flow now. So here, for example, in a Maven project, I have source main web app, I have flow 1, flow 2. Now remember, this directory name and the first entry point is same. So flow 1 and flow1.xhtml. that sort of becomes the entry point to your flow. Or if you don't want to keep the convention, then you can actually specify flow2, keep that name, and dash flow.xml. So either you can follow the convention, or you can override it via a configuration where you can specify exactly how the flow is going to look like, in which case you will define the entry point in this. And then of course the exit. So typically what you will do is, say flow1.xhtml is your entry point. You're going to click, click, click. You're going to navigate through the pages, and then you'll exit at some point of time. You can have arbitrary nesting of flows as deep as you want, but it's just like if-else loops. You can go only so deep, after which you lose track. There is a flow scoped annotation, so you can annotate a bean with @flow scoped, and what that means is your bean can store flow scope local variables now. The bean will be accessible, or the bean instance is really tied to a flow. If you try to access the bean in an expression language in a flow, it will be available, otherwise not be available. You can also define the flow definition programmatically using @flow definition annotation. So for example, let's say you are not following this convention, you are not following this convention, but you want to define it more programmatically. I'm going to know the details at the runtime. Then you can start defining it programmatically using @flow definition annotation. There are also EL expressions like flow scope, or whether you are in a flow or not. So all of those elements are available to you in a standard JSF page. JSF also defines a resource library contract. The idea is, with JSF 2.0, the idea was to have simple look and feel kind of concept, or standard look and feel. So you can say true MVC. Your view is using XHTML and CSS. Model and controller are sitting back in the EJBs and JPAs. Okay. Now this kind of takes that a step forward. So you can say, I have just index blue.xhtml and index red.xhtml, and in the webinf directory, webinf lib, I have this snapshot.jar. And just to kind of highlight what exists in that, I have metainf contracts directory with blue and red names in there. And there I can start defining what my templates are going to look like. Okay. So once I define what my templates are going to look like, I just need to share this single jar file with rest of my applications. And then they can get a standard corporate look and feel. They don't need to bundle in a specific directory. Just drop it into webinf lib. You can go a step forward. You can say, what? I have an app server wide library directory. I'm going to drop this contracts in there, and it'll get resolved appropriately. So in my XHTML page, basically, all I'm going to say is, this is within a view tab, and I'm going to specify the contracts as red. Okay. JSF also defines pass-through attributes. So if you take, for example, if you define a h:\input text with type equals email over here. Now, the way JSF works is, there is a rendering component, there is a HTML render kit at the back end, or a UI component. Those two together work to generate the corresponding HTML for you, which is then presented back to you. Now, in this case, if I have a h:\input text, this will really generate to the type:\email would be converted to type:\text, because it says, hey, I don't understand what type:\email is, but I know this is input text, so type is going to be text. Now, with HTML5, there are new data store attributes or type attributes that have been introduced. So, for example, I could say type equals email, and then I'm specifying p:\type. Okay, the moment I say that, p: is just a random prefix that I've chosen, but the idea is it really belongs to a standard pass-through namespace, which is defined by the specification. By pass-through, it means is, there is no UI component or HTML render kit corresponding to this element. I don't know how to render it, but you pass it along. So this way, this guy will actually, or the JSF runtime will say, okay, type:\email will be passed over as is to the front end page. The user agent, which is my browser in this case, knows how to render it, so it will render it nicely. And if you look at it in a Chrome or any of the modern browsers, if it's a color palette, so if you say type equals color, for example, if you click on it, it automatically pops up your color palette. So those are your standard HTML5 elements, or even data store attributes. You can just say p:\data store, whatever the name attribute is, and it will be passed over to your HTML page. JSF also has a file upload component finally, after many, many years. It is tied to my corresponding upload bean on the backend side. This capability was added in Servlet 3.1, so it's tied to that. Won't dig into the details. All right, so let's talk about JAX-RS. JAX-RS was primarily focused on server side so far. You could take a POJO, put an annotation on it, and that POJO is published as a REST endpoint. Now with JAX-RS 2.0, there is a brand new client API that is being added. So you could say, client builder is really my entry point to the client API. So you can say, I'm going to build a new client. On the client, I'm going to set up a new target. Target is the endpoint of where I'm going to invoke the REST, where my REST endpoint is hosted. Then I'm going to build a plain invocation object. I could use this invocation object later, or I could use this invocation now. In this case, I'm using it now, so I'm saying invocation.invoke, and I'm getting a response object. Okay? And then on the response, that's one way of getting a response. The other way is you can just use a clean, fluent API. So you say build a new client, set up a new target, build the request, and get it. So there are both the options are available. Another option over here is, in this case, I'm saying get string.class. So for example, you're still invoking HTTP GET method over here, but you're explicitly specifying, I don't care about what's on the wire format, just give me the data back as string. So presumably the JAX-RS runtime, or REST Easy in case of Wildfly, has that baked in there, which it says, oh, the response is coming like a string, let me convert it into string. Or another way is, you can think of this as, you can, in the request, you can say media type as application JSON. So you want to capture the JSON request, which is on the wire. And then you can still say get string.class, and you will get actually the JSON payload that is being exchanged on the wire. JAX-RS also introduces the concept of async client and async server. So async client, for example, all you're saying is, you're just going to introduce a new keyword over here called as async, and that's it. Just that single keyword will take care of it, and it's going to return a future object to you. So with future, again, you can say, I'm going to get the value over here, and you can keep trying it. It's a standard JDK design pattern, so nothing fancy here, but leveraging and providing a lot more cohesive application development experience. On the server side, the API is not very clean, in my opinion, at this moment, but effectively what you say is, as soon as I get the method, or this is my async resource on this path, this is HTTP GET. As soon as you get, you say suspended. So the method gets suspended basically, but effectively you are delegating it to a new thread. Now I shouldn't really be using new thread over here. I should really be using the JDK or the concurrency utilities. And that's where the API is not very clean. That should I be using a new thread, or should I be using at suspended? So I think there is definitely a scope for improvement over here. Hopefully JAX-RS 2.1 will take care of that. In order to do your cross-cutting concerns, JAX-RS also introduced message filters and entity interceptors. Now remember, there is a client side and a server side, request and response, request and response. So there are 4 points where all of these messages are intercepted. So message filter, think about it as primarily targeted towards HTTP headers. Okay, so you can see client request filter, client response filter, and similarly for container request and response. And the way you do that is you just implement an interface, you get a context object, very standard thing, you get the method name, get the URI, and other details about it. Entity interceptors, on the other hand, are targeted towards the actual payload, filters towards headers, interceptors towards payload, because this is when the entity has to be bound. By entity bounding means, see, HTTP headers are available to you on the wire itself. By entity bounding means you may have to invoke business logic. You may have to query into the database or something like that. So entity interceptors are a little bit costlier operation by design, and that's why they're kind of split up, filters or interceptors. So you make an explicit decision. If you were, a classic example over here is, for example, let's say you receive a gzip header that your entity is gzip. Then you can dynamically plug in your ungzip entity interceptor, which will automatically ungzip the content for you and present you with the real content for yourself. JSON-P. This is a brand new API, JSON 353. It provides a low-level API for JSON parsing. Okay, so here, for example, I'm saying create object builder, add name values, so ID, is 1, 2, 3, 4, date is so, total amount so and so. And then to this name value pairs, these are 3 name value pairs, I'm adding another nested object, which is named object, so customer, and then I'm creating another object builder over here. So as you can see, this is a lot more lower level API, which is like JAX-P. Okay. Similarly, there is a parser. So I can say, okay, I'm going to parse and I'm going to read it from a file this time. So I'm going to just read it from a file, and the parser is going to generate events for me. And events are like start of an array, start of an object, end of an array, or a value. So it's a streaming parser. Now remember, these are very low level APIs. The higher level API, which is JSON binding, where you can take a POJO, put an annotation on it, say, go do some magic for me, just like JAX-B, hopefully should be there as part of Java EE 8. At least that's the plan we have heard. Batch. Now batch is a brand new addition to the Java EE 7 platform. A typical workflow, this is actually from Spring Batch. A lot of work in the batch specification has come from Spring Batch. So the concept is, you have in a batch, you have a step. You will have a reader, a processor, and a writer. So the idea is, think of this as receiving a CSV file with thousands of records at the end of the day. Then at the end of the day, you want to read the CSV file, validate it, and put it into a persistent database, for example. Now for each read, you may want to process, or you do want to process actually, validate the record, but you may not want to write it because it could be a costly operation. So you may want to read it, process it, and aggregate it. And that's why what you see here is you read, process, and you bulk up a bunch of items, and then you do one persistent write to the database. And all of this, between execute and exit status is a container managed transaction, is automatically run in a container managed transaction. So either the whole thing succeeds or the whole thing fails. So there is automatic checkpointing, everything kind of built into the batch API itself. Now the entry point to the batch is a job specification language. And this is sort of an example of how a job specification language looks like. So as I said, job has a step. Step in this case is a chunk. Chunk is basically item-oriented processing, as I was saying. You have a bunch of items in your CSV files. You're reading an item, processing an item, and then writing it after aggregation. So reader, processor, and writer elements are in there. These are your corresponding beans. You're specifying how many items you want to aggregate before you write them out. So this is my simple reader. I'm saying implements item reader. I'm reading an item. So maybe you're reading your item using JPA. It doesn't matter what the input stream is. Could be a JMS stream, could be a REST endpoint, could be a file. It doesn't matter really. But there are methods by which you can override and initialize your item reader. Then there is an item processor where whatever item was just read, this object is actually fed over here. You can read an account and return a statement, for example. So if I do a monthly email statement, for example, account could be a POJO, statement could be a JPA object, completely different objects, and that is perfectly valid. And you can ignore, or you can say the account object doesn't look valid, so I'm not going to process the statement for this account this time. And finally, you have an item writer. So in this case, whatever object item is being returned over here is aggregated in this list parameter over here, and you can use Java Mail to send email. So true Java EE kind of programming on how you can do batch programming in Java EE 7. Batch also provides ad hoc jobs as well. So you can just want to do one-time job of, okay, this is a task-oriented processing. Task is send an email or upload a file, and that's called as batchlet. There are listeners available at job. Job could have multiple steps. There are listeners available at each step and each chunk. So for example, I could say my step listener, chunk listener, even read, processor, and writer listener. So there are kind of pre and post hooks available in all the cases. And these are available as interfaces and abstract classes, just for convenience. So for example, here I'm saying extends my abstract job listener before job and after job. If you want to do some initialization and cleanup before and after the job, you can do that. Or you can listen for certain values, or you want to trigger somebody, you want to tell somebody that I'm doing something. Now this is what we call as a declarative partition of jobs. So for example, I can have my reader, let's say I have my processor and writer, but I'm running on a multi-core machine, which is very common these days. This is actually the default actually. So you could say I want to read thousands of records, or say a million records to be simple, and I have a 2-core machine or a 4-core machine. Then I can start splitting up my job into multiple partitions. I'm going to pass 2 properties, start and end, and I'm going to define that as a partition plan start and partition plan end. And where is my partition plan defined? Here in my job XML, I'm saying this is a partition. It's got 2 partitions. This is my partition 0 start and end value. This is partition 1 start and end value. So literally based upon what is your deployment environment, you can start specifying this partition as part of job XML. Now, you may not be able to do that all the time, in which case you can define this programmatically as well. So there is programmatic and declarative ways of splitting up your partition. Now, your readers, processors, and writers need to know what the start and end values are. So those values need to be available in there. You can also start creating workflows within batch. So for example, you could say, I'm defining a flow as a matter of fact. So all the elements within flow execute as one unit. So you could say flow is step 1, 2, and 3. So, and then you can say flow 2 is step 4, 5, and 6. And then you can say flow 1 executes first before flow 2 gets executed. So in this case, I'm saying this is my flow 1. After flow 1 completes, then I'm saying the next flow is step 3, or it could be either a flow or a step. So there's a very complex, I wouldn't say complex, but there is a very comprehensive workflow mechanism that is available as part of job specification language. So here in this case, I can start splitting up. I can do concurrent execution of flows as well. So I'm saying these are my 2 flows, run them concurrently. I can't wait. I need to finish the job faster. So it's very comprehensive process over here. And here I'm creating more workflows. So for example, customized way of sequencing between steps, flows, and splits. So here I'm saying my decider implements decider. I can say I can look at all the step executions that are available to me, and then I can return a particular job status. And based upon that job status, whether it's loaded or not loaded, I can say go to this step or don't do anything. In this case, I'm saying if the result is not loaded, then just end the job right there itself. So programmatically and declaratively, both of these things are pretty much symmetrical in that sense. Java Mail, not a whole lot of addition, but further simplification. You could start creating your resources annotatedly. So just like we did it in JMS or data resource, you could just say mail session definition, and this is actually a functional mail session definition. So you could say java::comp my mail session, and this mail session would be automatically created for you in your application server without giving a deployment script. Similarly, in JCA, you can create a new connection definition or administered object definition. And default resources. One of the big changes in Java EE is, hey, you're building a Java EE application, you are most likely using a database resource. And if you're using a database resource, we are trying to lower the bar for entry. There is a default, for example, JDBC resource available. So if you bring up Wildfly, which is Java EE7 compliant app server, then in Wildfly, for example, it has a H2 in-memory database. And in your persistence.xml, for example, if you don't specify any data source, it will automatically bind to the default JIND name that is defined as part of the platform. So that kind of makes it simple for you. You can get started with that at least, and once you are ready, then you can start creating your custom JNDI names and start playing with it. But that's kind of lowering the bar. So not just a default data source, but there is a default JMSConnection factory as well. And even there are JIND names for several managed objects or concurrency managed objects. This talk was originally given by myself and Antonio. Antonio is a Paris Jug leader, organizer for DevOps France. So the pitch was to buy our books. Everything that I talked about, this complete slide deck is pretty much derived from a bunch of samples, about 200 plus samples that are on the GitHub project over here. And to me, really, code is king. So if I go here, for example, so here, you can see all the code samples that are existing. There are about 32 contributors. So a lot of people have actually contributed to this. So you can, so you can see there are samples for each and every technology. If you want to learn about WebSocket, so you click on WebSocket, and you can see there are about 30 plus samples just on WebSocket itself. Or if you want to learn about, for example, batch. So you click on batch, and there are about 15 odd samples in batch. Each of these run as Orkillian tests on Wildfly. So if you go to the top of the project here itself, then you can see the batch or the CI job running, and you can look at the current status. So for example, running on Wildfly, there are about 14 failures, and what I'm trying to tell you is we are looking for pull requests. By any means, if you can send us pull requests that, hey, this test is broken and this is how we can fix it, or these are the new samples that I would like to incorporate or submit it, by all means, we are looking for that. Another one that I want you to encourage is take a look at the Java E7 hands-on lab. This is a self-paced hands-on lab that walks you through for building a complete end-to-end Java E7 application. It's about a 70-page lab, so it's pretty comprehensive, but it shows you all the design patterns and anti-patterns as well, what to do and what not to do in terms of Java E7. So by all means, these are all on GitHub. Share it, fork it, pull requests, all of that is welcome. As I said, all of these samples run very well on Wildfly. I personally make sure that they run on them. And if there are issues, most of the issues are known issues for us. But if you see any particular sample is missing, we are more than welcome to take pull requests. And that's about my time. Well, we have time for questions? We don't have time for questions. Okay, I think I'm going to be hanging outside the room in that case. Thank you.